everybody. So I have a specific question to answer here. So if you have access, you can go to PrepTest for Game 1 to check this one out, but I'm just going to be reviewing question 4. So in this game, we have a lot of players. We have 9 of them: F, G, H, I, J, K, L, M, and N. And they're all arranged in a web. So K has the highest position, and then everybody else is somewhere below K. And they kind of fall into these two lines. So this is how I would write out the original diagram. We're not told that each of these players has a different position, so it's actually possible that we could have ties here. But the only way that we could have ties is between players that don't have a known relationship to one another, where they actually have different positions relative to each other. So L or N could have the same position as any one of these other players. L and N can't have the same position as one another because L always has to be higher than N. So that's important for question 4. So with question 4, we're given a question-specific condition, and then we're asked what must be false. Okay, so if N is the same, has the same position, okay, as one other player, though that player would have to be either I, F, M, G, J, or H. Okay, so we have 6 options there for players that could be tied with N. In all of those cases, K and L are still going to be ahead of N. But it's possible, for example, that I could occupy the same position as N, and then F, M, G, J, and H would all be after I and N. That's possible. So here is one extreme of this scenario, that I and N would have the same position. Another extreme is that N and H would have the same position. So we'd have K, L, and N would have the same position as H. All right, and then these guys here, starting with I, everybody else is going to be somewhere between K and H, right? So all of these guys here will just be somewhere in between. Okay, so rather than creating every single possible world where N has the same position as another player, I've just shown the 2 extremes. And I think that one of the keys to this question is understanding how L gets involved here. So in this scenario, because L is higher than N and N has the same position as I, L ends up being higher than all of these players. But in this scenario, we only know that L is higher than N and lower than K, but it could jump in any of these spots. So L's position relative to all of these players is unknown. So L could be higher than I, lower than I, higher than F, lower than F, and so on. What we do know, though, is that if N has the same position as one other player in this line, that L can only be higher than H. Okay? So that's how we get to the correct answer here. Right? Because the correct answer is D, which states that L is lower than H, right? So because L actually must always be higher than H, this is the answer that must be false. Okay, this cannot be true. Right, so hopefully that helps to clarify that one. Let me know if you have any further questions about this game or about how I arrived at that answer. Okay.